Hello everyone. In this video, let's discuss how to write a program to find minimum depth of binary tree. Given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from root node down to the nearest leaf node. A leaf is a node with no children. So here they have been example as 3, 9, 20, null, 15, 7, which is 3 is a root, 9 and 20 are the children of 3, and for the node 9 we doesn't have any children, so both are null, and 20 has 2 children, 15 and 7, and the output is 2, which is nothing but the depth is 2, that is minimum depth is 2 and the maximum depth is 3. So this is level 1, this is level 2 and this is level 3. So here the maximum depth is 3 and the minimum depth is 2, that is why we have got the output value as 2. Let's take the second example. So here they have given 2 null, 3 null, 4 null, 5 null, 6. So here 2 is the root node. Okay, we'll have 2. Then we'll give enter. Here null. So left child of 2 is null. Right child is 3. So I'll go for 3. Then I'll go for left child of 3 is null and right child is 4. Okay. Left child of 4 is null. Right child is 5. Okay. Left child of 5 is null. Right child is 6. So here the minimum depth can be calculated as number of nodes along the shortest path from the root node, from this is a root node to the nearest leaf node. So here which is a leaf node? So this is a leaf node. So how can I say whether this is a leaf node? Because the left child and right child both are null, so that I can say this is a leaf node. So the nodes with the value 3, 4, 5 are not leaf nodes. So the minimum depth is 5. That is why we have got the output value as 5 here. Let's discuss the logic in detail. To solve this question, you need to know how level order traversal works. So if you are not aware of level order traversal, I have given the level order traversal link in the description. Please watch it and then come back to this question. Fine. Now let's see how to solve this question with the help of level order traversal to find the minimum depth of binary tree. Okay. So first we have to check the root value. So here let me take the root. So root is having the address called 100. Let's assume the address of root to be 150. So initially what I have to do, I have to check whether my root is equal to null. So if root is equal to null, what I have to do? I should return. Okay, fine. We have to take Q for the level order traversal. So I'll declare a Q. Tree node. We are going to show the address. So I have to give tree node. Name I'll give it as Q equal to new list. Okay. Now initially I'll be taking the level as 1 because this is first level and this is second level and this is third level where we are having the leaf node, that is the depth. So here on the second level we have the leaf node, so the depth of the tree is 2. So initially I'll be considering the level value as 1 because we have a root value. Whenever we are having a root value, that depth is considered to be 1. So that is why I have given the variable level and I'll issue the value as 1. And before which what I have to do? I have to take a Q. Okay, I'll take a Q. Okay. Fine. So first what I have to do is, before declaring the variable level, I have to take the root and I have to add it inside my Q. So Q dot add root. So root value is 100, that should be inserted inside my Q. Done. After this, I have to take a loop and I have to check a condition saying that whether my Q is not empty or not. So Q dot is empty. So if the Q is not empty, first I have to find the size of the queue. The reason why are we finding the size of the queue in the sense that denotes the number of nodes we have in that particular level. So I'll be taking a variable called size and I'll give Q dot size. So here we are taking one more variable called size. So the size of the queue is 1. So which means we have only one node in the first level. That is the actual meaning. We have only one node in the first level. So now I have to take a for loop and I have to iterate up to size times. So for int I equal to 0, I less than size I plus plus. So once after going inside the for loop, I will be iterating all the nodes of this particular level with the help of this for loop. So first I have to pop the front element of the queue that has to be stored in an object. So I will be taking an object called current. So I have taken an object called current. So here what I will be doing, I will be popping the front element of the queue and that will be stored in an object called current. So queue.poll. What is the purpose of the method poll? It will pop the front element of the queue and that will return. So the returned value will be stored in an object called current. So I have to pop the front element of the queue 100, that should be stored in current. Done. Afterwards, I have to know whether this is the minimum depth or not. For that, I have to check one condition, whether this node is the leaf node or not. How can I know whether the node is leaf node or not? If current.left equal to null and current.right equal to null. So if the condition is true, what does it mean? It is the leaf node. So we have reached the minimum depth of the tree. I have to return the level value saying that this is the minimum level. So here current is pointing to the memory location equal to 100, current.left equal to null, condition becomes false. If the first condition is false, I don't want to check the second condition because we are going to get the value as false only. So it will not go inside the if condition. Now what I will be doing, I will be taking the left node's address that should be inserted inside my queue. For that I have to check a condition saying that if current.left not equal to null, if current.left is not equal to null, that should be added inside my queue. So current is 100, current.left is 200, 200 not equal to null, so that I will be adding in queue. Current.left. So 200 I will be adding in my queue. And then I have to check the right child also. So to check the right child, I have to write one more if condition, that is if current.right not equal to null. If the condition is true, I will add the right child address inside my queue. So 300 I will be inserting inside my queue. After this, I will close the for loop. Then I will go for the next iteration. So I value becomes 1. 1 less than 1 condition becomes false. In the first level, I have iterated all the nodes. Then I have to go for the next iteration of my while loop. Before going to the next iteration of the while loop, I have to increment my level value because we are going to the second level. So level value will be incremented and then I will close the while loop. Now I will check whether the queue is not empty. Yes, queue is not empty. If the queue is not empty, first I have to find the size of the queue. Why are we finding the size of the queue? To know the number of nodes which is present in this particular level. Size of the queue is 2. So 2 will be stored in the variable size. So which means I have to iterate the for loop for 2 times. Which means we have 2 nodes as of now. So in these 2 nodes, if we get any of the leaf node, directly we can return the level value. So here we have to take the front element of the queue 200. That has to be stored in an object called current. After storing that, which means I am currently in this particular node. Now check whether the current.left is equal to null. Yes, condition is true. So I have to check the second condition also because according to AND we have to satisfy both the conditions. Current.right is also equal to null. If the condition is true, return the level value. Previously level value was 1. So I will be incrementing the level value by 1, which is 2. Currently level value is 2. So I will return the value 2 from this function saying that the minimum depth of the binary tree is 2. Which is this is the minimum depth. First level, second level. So this is the output value. We have got the output value as 2. This is the logic of finding the minimum depth of the binary tree. Let's try to implement it as a program. Okay. So first I have to check whether my root is equal to null. If root equal to null, I will directly return 0. Okay. If not, first I have to declare a queue. Queue equal to new linked list. Fine. Then I will be adding queue.offer root. Fine. After this, what I am going to do, I have to declare a variable called level. I will initialize a value as well because root is on the first level. Now I have to check whether my queue is not empty. So not of queue dot is empty. If the queue is not empty, I have to find the size of the queue. Why are we finding the size of the queue? It tells us the number of nodes in this particular level. So I will be taking a for loop and I will be iterating that size times. So I less than size I plus plus. So first what I have to do, I have to create an object. So tree node current equal to queue dot pull. Okay. So I'll pop the front element of the queue, that will be stored an object called current. Now I'll be checking whether this node is the leaf node or not. How can I know whether the leaf node or not? If current dot left equal to null and the current dot right equal to null. If this condition is true, it is a leaf node. So directly I can return the level value from this particular function. If not, I have to check whether the left child is not equal to null. If the left child is not equal to null, I have to add it inside my queue. So queue dot add, or you can give offer, queue dot offer current dot left. Similarly, check whether right child is not equal to null. If right child is also not equal to null, add the right child address inside my queue. So queue dot offer current dot right. So what is the purpose of the method offer? In the sense, it will add the element, and if the element is present and it returns true. If the element is not present, it just returns false. It will not throw me any exception. That is why we are using the method called offer for adding the element inside my queue. Then after the iteration, what I have to do, I am going to the next level. So level value will be incremented. Then I will close the while loop. So after closing the while loop, I have to return the level. In case for the second example, at that point of time we have to return the level value, right? Fine. I will come after coming out of loop. I have to return the level value. That's all. This is the logic of the program. Let's run the code now. Yes, it passes all the test cases. That's all.